Assalamu alaikum. In this video, I will guide you about the chapter 9 of the heart physiology. इसमें मेरा main focus होगा जो important topics है आप लोग को वो बताऊंगा and important SCQs, important MCQs और brief elaboration of concepts. इसमें मैं ज़्यादा elaborate नहीं कर सकता because ये बहुत काफ़ी लंबा चैप्टर है और बहुत ज़्यादा टाइम का हो जाएगा, तो मैं सिर्फ ब्रीफ एलेबोरेशन करूँगा ताकि आप लोग को अंदाज़ा हो जाए कि कौन सा क्वेश्चन किस तरह और कैसे पूछा जा सकता है और उसमें हमने क्या लिख के आना है. तो फर्स्ट ऑफ ऑल वी विल सी द फर्स्ट पेज. So in this paragraph, the first paragraph of this chapter, what they can ask us, they will ask us the characteristic of heart muscle. So what are the characteristic of heart? So there are few characteristic of heart which I will tell you, or you can prepare this topic from JP because it is not very well written in guyton. So what are the characteristic of heart? First characteristic of heart is automaticity. Heart is automatic. Heart has rhythm, cardiac rhythmicity. So what is cardiac rhythmicity? Heart continues to contract. You can आप अपने हार्ट को ऑर्डर नहीं देते. You don't order your heart, it keeps on contracting. This is the automaticity of heart, and this is due to the SA node. SA node keep on firing the action potential, as a result of which your heart keep on contracting. The next important point is heart muscle is excitatory. Heart has conductivity, heart has contractility. So these are the important points. These are the important characteristic of heart, which you should know. These can be asked in Viva. So on the next, on the right side, you can read this topic, physiological anatomy of the muscle. It can be asked in Viva or MCQ's question, and it will help you to clear your concepts. So next important point is what is cardiac muscle is syncytium. What is syncytium? So basically syncytium हमें कोई भी चीज़ syncytium होती है ना वो इकट्ठे कॉन्ट्रैक्ट करती है. आप लोगों ने बस ये बात रखनी है. What is वो इकट्ठा क्यों कॉन्ट्रैक्ट करती है उसकी कोई वजह होगी ना. its reason is they gap junctions are present. What are gap junctions? Gap junctions connect the cardiac muscle fibers. So for example, these are the cardiac muscle fibers, then these are the gap junction which decrease the resistance between the cardiac fibers, so current can easily conduct through it. For example, कोई हमारे घर जो दरवाजे हैं इसमें से हम गुजर सकते हैं, ये रेजिस्टेंस नहीं देंगे, कम रेजिस्टेंस देंगे. अगर वहाँ पे दीवार हो तो हम दीवार को तो नहीं तोड़ के जा सकते ना, बट दरवाज़ा और दरवाजे को खोल के जा सकते हैं. सो बेसिकली गैप जंक्शन दरवाजों का काम करते हैं. ये एक फाइबर को दूसरे फाइबर से कनेक्ट करते हैं. हमारा जो एट्रिया है ना वो आपस में एट्रिया के मसल फाइबर्स कनेक्टेड है. थाउजेंड्स ऑफ मसल फाइबर्स होते हैं वो कनेक्टेड है थ्रू गैप जंक्शन. सिमिलरली आवर मसल फाइबर्स, कार्डियक मसल फाइबर्स इन ventricular muscles are also connected through gap junction. So there are two syncytium of our heart, atrial and the ventricle. So atria contract इकट्ठा contract करेगा. Similarly, our ventricle also contract at the same time. Right and ventricle contract at the same time. So ये heart की property है और ये property की reason gap junction है. तो ये पूछा जाता है. Next is action potential of cardiac muscle. It is very important for MCQs. So you can see the value -85. So cardiac muscle has resting membrane potential of -85. And maximum action potential what cardiac muscle can achieve is positive 20 millivolt. So what is the difference between -85 and positive 20 millivolt? If you see the difference, it is 105 millivolt. So 105 millivolt is the difference. और ये हमारे पास क्या करता है, हार्ट को स्ट्रेंथ प्रोवाइड करता है कॉन्ट्रैक्शन की. सो वी कैन सी हियर द ग्राफ फॉर द वेंट्रिकुलर मसल. So its resting membrane potential is -85 almost, and its maximum action potential is positive 20, and the difference is 105 millivolt, which can be asked. Let's suppose in any condition, if this difference of 105 decreases or it become 90 or 80 or 70, if it decreases from 105, then heart becomes flaccid and its force of contraction will decrease, and you will see it in the last of this chapter. At the end of this chapter I will explain this concept as well. So ये इसमें से पूछा जा सकता है. Then you can see here another graph which is of Purkinje fiber. What are the Purkinje fiber? Our heart has a conducting system. It is similar to the wiring in our houses. You can see that in our house we have wiring, electrical wiring, which supply different appliances like AC, like TV. So let's suppose atria and ventricle are appliances, and the conducting system is wiring of our heart. So what is the wiring of our heart? Main supply. What is the, you know that there is a main supply of electric current. So SA node is basically the electrical house or pacemaker of the heart. So electrical supply is provided by SA node. Now it, with the help of internodal fibers, move toward the AV node. So after AV node, it further go into the right and left bundle fibers, then into the Purkinje fibers, and Purkinje fibers then supply to the ventricle. So these are the Purkinje fibers. The most important question which can be asked, which fibers in our heart and have highest velocity? So Purkinje fibers have highest velocity. You can see it in the next part of this chapter. So the next important question, they usually ask what is the difference between the action potential of skeletal muscle and the cardiac muscle. So what is the first difference? The action potential in the skeletal muscle is generated by fast sodium channel only, but action potential in cardiac muscle is generated by fast sodium channel and L-type calcium channel. So this is the first difference between the skeletal and the cardiac muscle. What is the difference? Second difference. Second difference, always remember that heart या ventricular muscle has plateau phase in it, but skeletal muscle, action potential of the skeletal muscle has no plateau phase. So you can see here this part. What is the second major difference? Due to the presence of the plateau phase, our action potential, प्लेट्यू फेज का क्या फ़ायदा होता है? जो प्लेट्यू फेज है ना, उसका फ़ायदा यह है कि ये हार्ट की कॉन्ट्रैक्शन को टाइम देगा, और due to the plateau phase, permeability of the potassium ion decreases, because what is the function of the potassium ion? Potassium ion basically repolarize the muscle. So if potassium ion's permeability decreases, it means it takes some time to repolarize. So if it takes some time to repolarize, then it will give some time to heart to contract. क्योंकि repolarization जब तक नहीं होगी तब तक वो contractility और उसमें वो current होगा. So ये important कुछ points है. Now this is the most important SEQ question of this chapter. What is the summary of the action potential of the cardiac muscle? So I will explain it from this diagram. It has 5 phases. You can see here 0, 1, 2, 3, and 4. Every digit has a meaning. What is meant by 0? This is depolarization. What is meant by 1? It is initial repolarization. What is meant by 2? It is plateau phase. What is meant by 3? It is repolarization. And what is meant by 4? It is used for hyperpolarization. So what is 0 and why it is 0? अब देखिए 0 क्या है? What is 0? It's depolarization. And how depolarization of heart take place? हमारी जो depolarization होती है heart की, it takes place when fast sodium channel open. तो फास्ट सोडियम चैनल जब ओपन होंगे तो ये सेल है, तो सेल के अंदर सोडियम मूव करेगा, एंड सोडियम इज पॉजिटिवली चार्ज, so our resting membrane potential move toward the positive charge. So this is depolarization of heart. Then initial repolarization take place. तो initial repolarization हमारे पास कैसे होती है? हमारे पास फास्ट पोटाशियम चैनल विल ओपन, और जब फास्ट पोटेशियम चैनल ओपन होते हैं तो कुछ अभी चैनल्स ओपन हुए होते हैं, क्योंकि पोटाशियम एज कम्पेयर स्लोली ओपन हो रहा होता है। तो कुछ ओपन हुए होते हैं कि कैल्शियम चैनल्स ओपन हो जाएंगे, एज अ रिजल्ट ऑफ विच फर्दर जो पोटाशियम चैनल ओपन होने थे वो बंद हो जाएंगे। तो सेकंड फेज इज अ प्लेट्यू फेज। इसमें कैल्शियम बाहर को मूव कर रहा होगा और पोटाशियम कैल्शियम अंदर को मूव कर रहा होगा सेल के, एंड पोटाशियम विल मूव आउटसाइड। सो ये बैलेंस हो जाएगा इनकी जो मूवमेंट है। तो यह यहाँ पे हमारे पास प्लेट्यू फेज आ जाएगा। The next phase is repolarization. So I have already told repolarization takes place when the potassium ion move out of the cell. Efflux of the potassium is responsible for the repolarization. Then hyperpolarization, -80 से भी अगर नीचे potential चला जाए. So what is the advantage of this phase 2 plateau phase? So basically due to the plateau phase, our heart cannot be tetanized. It is a very important question which is usually asked in Viva, why our heart cannot be tetanized. Our heart cannot be tetanized because of this plateau phase. तो इसमें क्या importance है? Basically इसकी वजह से our refractory period is prolonged. What is the refractory period? It is almost 0.25 to 0.30 second. There are two types of refractory period: absolute refractory period and relative refractory period. What is the difference between them? जो absolute refractory period होता है, इसमें for example your heart is in refractory period. आप जितना मर्जी स्ट्रॉन्ग एक्शन पोटेंशियल देंगे वो कॉन्ट्रैक्ट फर्दर नहीं होगा, वो अपनी कॉन्ट्रैक्शन कंप्लीट करेगा आराम से जो कर रहा है। उसको बेशक जितना मर्जी स्ट्रॉन्ग स्टिमुलस आ जाए वो अपना पहले ही कॉन्ट्रैक्शन कंप्लीट करेगा। एब्सोल्यूट रिफ्रैक्टरी पीरियड वो है। व्हाट इज रिलेटिव रिफ्रैक्टरी पीरियड? अब रिलेटिव रिफ्रैक्टरी पीरियड में अगर हार्ट को बाहर से स्ट्रॉन्ग स्टिमुलस आता है, वो कॉन्ट्रैक्शन कर रहा था, स्ट्रॉन्ग स्टिमुलस आता है, तो वो हमारे पास तब कॉन्ट्रैक्शन अपनी न्यू कॉन्ट्रैक्शन यानी प्री मेच्योर कॉन्ट्रैक्शन करेगा अगर बाहर का स्टिमुलस बहुत ज़्यादा स्ट्रॉन्ग होता है। अगर वो नॉर्मल स्टिमुलस होता है तब उसको कोई फर्क नहीं पड़ेगा, बट अगर बहुत ही ज़्यादा स्ट्रॉन्ग स्टिमुलस आता है ना, तो फिर हमारे पास अगर वो रिलेटिव रिफ्रैक्टरी पीरियड में है ना, तो प्री मेच्योर कॉन्ट्रैक्शन होगी। इफ इट इज़ इन एब्सोल्यूट रिफ्रैक्टरी पीरियड तो कॉन्ट्रैक्शन नहीं होगी, वो अपना साइकिल कंप्लीट करेगा। और जब वो रिफ्रैक्टरी पीरियड में से निकलेगा देन नेक्स्ट स्टिमुलस कैन वर्क, तो नेक्स्ट स्टिमुलस का फायदा होगा। So you can see here in this diagram, this is the refractory period, this is the absolute refractory period up till here. यहाँ तक absolute refractory period था। तो if you give a very strong stimulus, ये तो it keep on contracting, ये अपनी contraction continue रखेगा जो कि शुरू हो चुकी थी। बट यहाँ पे रिलेटिव रिफ्रैक्टरी पीरियड आ गया। फॉर एग्जांपल इधर आपने कोई बहुत ज़्यादा स्ट्रॉन्ग स्टिमुलस दे दिया, अब बहुत ज़्यादा स्ट्रॉन्ग स्टिमुलस की वजह से अर्ली प्री मेच्योर कॉन्ट्रैक्शन विल टेक प्लेस। अगर आपने इस जगह पे स्ट्रॉन्ग स्टिमुलस दिया, अभी ये खत्म नहीं हुआ था, तो लेटर प्री मेच्योर कॉन्ट्रैक्शन विल टेक प्लेस। सो दिस इज द डिफरेंस बिटवीन द रिलेटिव एंड द एब्सोल्यूट रिफ्रैक्टिव पीरियड व्हिच इज रिपीटेडली आस्क्ड इन वाइवा। And absolute refractive period is due to this plateau phase. So plateau phase has great importance in our heart. Plateau phase is not present in the skeletal muscle action potential. That's why our heart is different from the skeletal muscles. So you can see another thing here. This topic is important for your concept. आप लोग को इस टॉपिक के कॉन्सेप्ट होने चाहिए, अदरवाइज इसमें से ऐसा कोई एससी क्यों नहीं बन सकता, बट इट कैन बी आस्क्ड इन एमसीक्यूज. This is a very important point. Our strength of cardiac contraction depends upon extracellular calcium ion. If you see contraction in skeletal muscle or the smooth muscle, they depend upon the intracellular calcium ion which are present in the sarcoplasmic reticulum. They depend on extracellular ions, but to some extent. But our heart muscle require extracellular calcium. For example, you take heart out of the body into a place where no calcium is present, calcium-free solution, your heart will stop contracting because calcium is responsible for the contraction of heart, and extracellular calcium has a great role in the contraction of heart. So if we remove the extracellular calcium, then our heart will stop pumping. So you can read it here. So this is a very important point which is usually asked in vivas. So next is the cardiac cycle. Complete cardiac cycle is very important. This is very important topic, and you have to read, you have to learn each and every point, because it can be asked in viva, it can be asked in MCQs, it can be asked in SCQs, everything. So I will give some important concept like diastole and systole. Diastole is a phase in which the heart is relaxing, and systole is a phase in which the heart is contracting. Diastole is a longer phase, and systole is as compared a shorter phase. So for this, you have to remember this diagram. This diagram is very important. It explains the complete cardiac cycle. So comes to the next point. It is these topics are related to cardiac cycle. So now come to this topic. यहाँ तक cardiac cycle complete होगा. अब इसके बाद this topic is also very important. These definitions are very important. And diastolic volume. As I already told you, diastole is the relaxing phase of the heart, relaxing. So end diastolic volume is the volume at the end of relaxation phase. So our heart is completely relaxed. So how much blood in our heart is in relaxed state? 120 milliliter. Now, what is end systolic volume? End systolic volume. Systole is a phase when the heart contracts. So when the heart contracts, volume is ejected. So at the end of the systole, only 50 milliliter will remain in the heart. For example, when your heart contracts, only 50 milliliter remain in your heart. So how much it is ejected? 70 milliliter. What is 70 milliliter? 70 milliliter is the stroke volume output, the amount of blood which is ejected. Then what is ejection fraction? Amount of blood which is ejected is stroke volume. Percentage of blood which is ejected is ejection fraction. For example, 70 milliliter is ejected from 120 milliliter. Now, how we can find it percentage? By multiplying it with 100, you will get 60%. 60% of the blood from the heart is ejected. This is the ejection fraction, and 40% remain in the heart. This 40% is basically end diastolic volume. So these definitions are very important. Next, about the backflow of the valves, you can read it, and in this there is an important question: what is incisura, aortic incisura, and how why it is present? So you will find the reason here in this. You can read this only. This is not very important, but it can be asked in viva. This blue tables is not important at all, but yeah, this part is important. You should know what is the reason of the first and the second heart sound and third and fourth heart sound as well, because you will read the abnormalities in chapter number 23. So work output of heart is not that important. So come to the next page. So this page is not that important at all. This is not important. This is not important. General analysis of the ventricular pumping. Next topic is also not important. So ये वाला page as such important नहीं, but this is important. This topic, ये सारा topic important है. You have to read this. Why it is important? On the next page, I will show you a graph. This is a very important graph. This is asked in Viva. This is asked in our prof. This is very important. This is basically the explanation of the cardiac cycle in a graphical form. So you should learn this. This is important thing. So the next topic, what is preload and the afterload, is very important. What is the concept of preload? What is preload? And diastolic volume. When our heart is in relaxed state, blood enters into the heart. So this blood enters into the heart, and due to this blood, heart पे load होगा. This is the preload. Now heart has to pump this blood, and heart has to pump this blood against the resistance which is offered by our blood vessels. So it has to pump against the resistance of blood vessels. So the resistance which is offered by the systemic and the pulmonary circulation is afterload. after. So preload is basically the end diastolic volume, or the more the preload, the more the tension in the cardiac muscle. And afterload is the resistance against which the heart has to pump. So this is the important definition. The next topic, you can read this. It is not that important, but you can read. Just give a read. Next, we come towards the next page. This is not that important. Where on the next page, regulation of heart pumping is not important. Intrinsic regulation. Yep, this topic is bit important. And the important thing is Frank-Starling mechanism. What is Frank-Starling mechanism? So as I told you earlier, our heart, and what is end diastolic volume? For example, this is our heart. Now it is in relaxed state. Blood enters into the heart. So more the blood enters into the heart, the more the muscle will stretch. For example, आपके पास एक गुब्बारा है, आप उसमें जितनी हवा डालते जाओगे वो उतना स्ट्रेच होता जाएगा, और जब आप उसको एकदम छोड़ोगे, जितनी हवा उसमें डाली होगी वो उतनी जोर से प्रेशर लगा के हवा को बाहर निकालेगा. सेम इज इन द केस विद हार्ट. द मोर द ब्लड एंटर इनटू द हार्ट, द मोर द मसल विल स्ट्रेच. हार्ट में ब्लड आता गया, हार्ट के मसल उतने ज्यादा स्ट्रेच होते गए. जब हार्ट ने अब कॉन्ट्रैक्ट करना है तो इस उसकी कॉन्ट्रैक्टिलिटी फोर्स भी उतनी ज़्यादा होगी. जितना ज़्यादा ब्लड उतनी ज़्यादा स्ट्रेच होगा और उतनी ज़्यादा स्ट्रॉन्ग कॉन्ट्रैक्शन होगी. सो दिस इज द फ्रैंक स्टार्लिंग मैकेनिज्म. व्हाट इज इट्स इम्पोर्टेंस? अगर हमारे पास ज़्यादा ब्लड आ जाता और उसकी कॉन्ट्रैक्शन कम होती तो कम ब्लड मूव करता. तो कम ब्लड अगर हार्ट से इजेक्ट होता तो हार्ट में हमारे पास ज़्यादा ब्लड रह जाता. उसकी वजह से डिफरेंट कॉम्प्लिकेशंस होगी. For example, pulmonary edema, peripheral edema. So Frank-Starling mechanism is very important because it makes heart to contract according to the blood volume present in the heart. So you should know it. What is this ventricular function curve is least important. You need not to read even. Next is control of the heart, sympathetic and the parasympathetic nervous system. This is very important. What is sympathetic nervous system? This is a part of autonomic system which is activated during flight and fight. Fear, during fear condition, fight and flight. So this is activated. So for example, you see a dog, your sympathetic nervous system will activate and your heart rate will increase. So basically your sympathetic nervous system increase the heart rate and your parasympathetic nervous system decrease the heart rate. So you should know the stimulation of the parasympathetic and the sympathetic nervous system in your heart. So sympathetic nervous system present all over the heart, especially on the ventricular muscle. But your parasympathetic nervous system, which is by vagus nerve, it supplies mainly in the atria, and a very least number of it fibers are present on the ventricle. So what are the vagal fiber? These are the parasympathetic fiber. So ये पूछा जा सकता है, for example, if you cut the sympathetic nervous system, then parasympathetic nervous system will dominate. As a result, heart rate will decrease. Similarly, if you cut the vagus nervous system, your sympathetic nervous system will dominate and your heart rate will increase. So this can be asked. So the next topic, this is effect of stimulation is not important. You need not read it. So come to the next topic. This is a very important for MCQs, especially for MCQs, repeatedly asked, and many people don't know the reason. What is the effect of the potassium ion? When there is excess of potassium, extracellular potassium, when there is excess of potassium, we will say there is excess of potassium. It means we are talking about extracellular fluid. So basically extracellular, if there is excess of potassium in extracellular fluid, you know that usually our intracellular potassium is higher. So extracellular potassium is increased from the normal value से ज़्यादा हो गया. What will happen? In the start of this video, I told there is a difference in ventricular potential is 105, -85 से +20 तक जाता है. So basically this difference is decreased in this case. For example, ये हमारे पास 90 हो जाता है. So due to the decrease of this difference, heart strength will decrease, heart contraction will decrease, heart टोनिसिटी डिक्रीज. तो बेसिकली इट मेक्स आवर हार्ट फ्लैसिड डायलेटेड बिकॉज हार्ट में वो स्ट्रेंथ नहीं है, तो वो उस अगर किसी चीज में स्ट्रेंथ नहीं है तो वो थोड़ी फैल जाती है. सो आवर हार्ट बिकम डायलेटेड when excess potassium is present because basically it decreases the resting membrane potential. For example, it will फॉर एग्जाम्पल -85 रेस्टिंग मेम्ब्रेन पोटेंशियल था, तो ये -85 से कम करके -65 समथिंग लाइक दैट इतना कर देगी. So this is the effect of extra potassium. Now if extracellular calcium will increase, so you know I have told you earlier that calcium is very important. Calcium is responsible for the contraction of our heart. So if there is excess of calcium in the extracellular fluid, it will increase the contraction of the heart. So it causes spasticity. So this is opposite to that of excess of potassium. If there is a deficiency of the calcium ion, then heart will become flaccid or dilated. So this is similar effect as a result, which we see as a result of increase of the potassium ion. So this is a very important point which can be asked in Viva. Then effect of temperature is usually asked in Viva, and this is very important, very easy to remember. You know, when you have some fever like 99 or 100 degrees centigrade Fahrenheit, so as a result of which your heart rate is increased, you will feel palpitation sometime as well. So basically how temperature increase the heart rate? When the temperature is increased, the kinetic energy of the ions is increased, as a result of which permeability of ions is increased. So everything takes place rapidly, due to which our heart rate will increase as well. So basically this is how the temperature acts on our heart. And the next topic is not that important, you can read it. There are only 4 to 5 lines. So this is about the chapter 9. I hope it will help. So you have to read these topics. So first topic is characteristic of heart, which you should know. Next, you should know about the what are the mechanism of generation of the action potential of the ventricular muscle, which can be asked. Next, you should know cardiac cycle. For I am talking this about the SCQ question. मैं ये SCQ questions बता रहा हूँ. Cardiac cycle पूछा जा सकता है. Effect of parasympathetic and the sympathetic nervous system on the heart can be asked. So these are the some important topics. और जो आप लोग को ग्राफ दिखाया था जो कि हमारे कार्डियक साइकिल को एक्सप्लेन कर रहा था, वो पूछा जा सकता है. डेफिनेशंस वाइवा में पूछी जा सकती है, और सिनेरियो पूछा जा सकता है फ्रॉम ejection fraction. For example, they will tell you the stroke volume, they will tell you the end diastolic volume, and they will ask you the ejection fraction. So आप लोगों ने फॉर्मूला लगाना है और ejection fraction बता देना है. So these are the important points from this chapter. I hope it will help.